Okay, so
geometry is so much better.
I don't know if this thing has started yet.
And bird race too. I would take geometry over algebra and
Yeah, I would too. Okay,
any freaking day of the week,
okay.
day or month.
Okay, lesson 18 is going to be graphs of rational functions. In fact, I want to take a quick look here to see. This is what they have as our goals. Identify horizontal asymptotes of simple rational functions from their equations. Interpret a graph of a rational function and explain the meaning of the horizontal asymptote in context. So our target is I can identify a horizontal asymptote from a graph or an equation of a rational function. So we're focusing on horizontal asymptotes today. That would be those lines that a graph approaches but never touches. Okay, so this one says, decide if each of these equations is true or false for x values that do not result in a denominator of 0. Be prepared to explain your reasoning. So they want to know if these are the same thing or not. Well, in fact, let me do this with you. Can I recall something with you? If I asked you to do the math problem 3/7 plus 2/7, do you know what you get for an answer? Okay, so you remember when you add fractions, you add the numbers on top, but just keep the denominator. Okay, so if you have this math problem right here that's in front of us, let's see, how can I explain this? Okay, let me do this with you. If I took the 1 plus 7 over x, and let's say I wanted to write this with a common denominator, any idea how I could do it? Because remember how when you add fractions, you're supposed to have a common denominator?
You put the 7 x to make it multiplication and put the x, 7.
Can you write the number 1 as a fraction?
No.
Yes. 1 over 1. All right. Whoop, darn it.
See, you missed it. Okay.
Yeah, it's okay. I mess up every day. Okay, so I get 1 over 1.
Okay.
Now, what would be the common denominator?
1.
Try again. X.
1.
X or 1x is the common denominator. So if I'm going to rewrite 1 with an x as a denominator, do you know how I would do that?
Magic.
Not magic. It's called math. You simply multiply the top and the bottom of the fraction by x. And I can legally do that because do you know what x over x is?
2x.
Nope.
1x.
X over x is just 1. Anything over itself
It's 1.
has a value of 1. So it's legal to multiply something by 1 and you don't change its value. That's really what I'm doing. I'm multiplying this fraction by 1 because I'm multiplying it by x over x. So 1 over 1 now becomes x over x. So I guess I'm going to ask you this. Do you believe that 1 plus 7 over x is the same as x over x plus 7 over x? If the fact remains that x over x is in fact 1. So you agree that these are the same thing. Okay, now do you remember that math problem we just did where I asked you to do 3 over 7 plus 2 over 7?
Sure.
How do you do this addition problem then?
7x over.
Whoa. Back here when you had the 3 and the 2, you did what math to
It'll
them?
be x plus 7.
You added them, right?
So it's x
X
plus
plus 7.
7 is x plus 7. They're not like terms. You can't actually combine them.
over,
Over the denominator.
x.
Okay. So I don't know if you understand what we just did, but we started with 1 plus 7 over x and we ended with x plus 7 over x. So we just showed using just math laws that they are the same thing. So for number 1, they are the same thing. Now, problem number 2. Oh boy, if I tried doing that same trick with this one, like let's say I said, okay, let's get a common denominator for the stuff on the right-hand side. You know what the common denominator would be? I mean, I can write 1 as a fraction, right?
Mm-hmm.
1 over 1.
Not these.
It'd have to be 7, so I'd have to multiply the top and bottom of this fraction by 7. So I'd end up with 7 over 7 plus x over 7. And then if I actually added this, I'd get 7 plus x over 7. And that does not look like the same as x over x plus 7. They're not the same thing. So I would say this one is not the same thing. Okay. All right, let's see what we got next here. Publishing a paperback book. Oops, too many things here. Let C be the function that gives the average cost per book. And that's what threw me off a little bit when I did this first time. They're averaging the cost per book in dollars when using an online store to print X copies of a self-published paperback book. Here is a graph of this. So this is the function. I'll make it a little bit bigger so you can see it. 120 plus 4x all over x. That is telling you what the cost per book is going to be based on how many books you're going to print. So just to kind of give you an idea here, if you were going to print 100 books, it looks like your cost would be a little over $5 a book. If you were going to print 200 books, your cost would be like $4.75 or $4.60 or something like that, something less than $5. If you were to print only 50 books, then you're up to about $6.50 per book. So you can kind of see what's happening here. It says, what is the approximate cost per book when 50 books are printed? What would you say then? 50 books are printed. Go up here and then kind of give me your best.
6.4.
So whatever you want to do, I mean, it's just got to be something close. So $6.50 maybe. It looks pretty close to that, right about in here. Okay, 100 books. What would it cost per book if you printed 100 books? Well, here's 100. $5.20 or something, I don't know. Something like that, sure. Okay. So, and it does make sense. If you print more books, it's going to be less per book. Okay, next up. The author plans to charge $8 per book. How many should be printed to make a profit? So let's go get that formula again. The cost per book is equal to 120 plus 4x over x. Now they want to charge $8 a book. So we need to replace this guy out here with an 8. So you should put your 8 out here. 8 equals 120 plus 4x over x. And now go ahead and solve this thing for x. It's okay with you. I think I want to get the x out of the denominator. So I think I should multiply both sides of this equation by x. Like this. So that the x's will cancel out on this side. And here I'm going to get 8x equals 120 plus 4x. Now you're just going to keep solving for x. Any idea what I should do next? What should I do next to solve this thing? Subtract 4x. Subtract 4x. I'm going to get 4x equals 120. And then go ahead and divide by 4. Okay, so if you want to charge $8 a book, then you better probably make more than 30 books so that you don't lose money, because you got to make a profit. If you make exactly 30, you won't make a profit. You'll break even. So you might as well say more than 30. So you're going to need to make more than 30 books to make a profit. Okay, so X represents the number of books you're going to print, and then the answer that you get tells you the cost per book. So let me ask you this question. What is the value of C of X when X is 1/2? So what is the value of this function C when X is a 1/2? So you're going to have to do 120 plus 4 times 1/2 all over 1/2. Well, 4 times 1/2 is 2, right? 2 plus 120 is 122. By 1/2. When you divide by half, that's the same as multiplying by the reciprocal. So that means that's the same as 122 times 2, which is 244, isn't it? So what does this mean? If X is a 1/2 and C is 244, what does that really mean in this particular problem?
The last, well.
Do you remember what X was? X was the number of books you're going to print. C, the answer is how much it's going to cost per book.
If the cost per book is going down by X amount.
X is the number of books you're going to print. So this is what's kind of ridiculous. If you're going to print half a book, it's going to cost you $244. That's what this thing is saying.
I love that.
So now it says, how does this relate to the context? Well, it doesn't really make sense. You're not going to print half a book. And if you did, you probably should get charged a lot because that's kind of ridiculous, something to do. But anyway, okay. So yeah, that doesn't make sense. What does the end behavior say about the context? The end behavior say about the context. All right, you've got this 120 plus 4x over x. Can we break this? I want to do this. I want to break this into 2 fractions. Are you okay with me doing this? It's sort of like I'm starting to break apart the addition, almost like I'm going to tell you to add these 2 fractions together, so you ended up combining them like this, but now I'm going backwards. Over here, I can cancel these x's. Cancel them out. So I'm going to get 120 over x plus 4. Now let me ask you a strange question. What happens to this fraction as x keeps getting bigger and bigger and bigger and bigger and bigger? Like if I got a 120 downstairs, this is a 1. So you're $5 a book. All of a sudden, this is a 240 down here. This becomes a half. Now you got $4.50 a book. That's right. So in fact, this is going to be a kind of a strange question, but let's say this thing gets incredibly huge, 10,000, 100,000, 1 million, 100 million.
It's going to be huge.
If you've got 120 over 6 billion, what number is that very close to? It's very close to 0. As this thing gets incredibly huge, this whole fraction almost becomes 0. This is what they want us to know because they're getting up near infinity, just cruising. This becomes almost nothing. So this thing is going to approach the number 4. The cost of those books is going to keep going down, 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 but it's never, ever going to quite hit 4. But it's going to get very, very close to 4. So this is a number that it approaches but never quite gets to. So now we're starting to talk about asymptotes again. So what does the end behavior say about the context? The more books you get, the closer to $4 it's going to be per book. So more books, closer to $4 per book. Okay, so this is where we're supposed to match these. Match the function with its graphical representation. So 4 over x minus 1. Actually, let me look. You might be right on that. Yes, you are right. How did you know that, by the way?
Because it's -1.
Yes.
Usually we're crossing
That's right. And it's going to get very close to -1, but not quite. It's just like that book problem we just did.
And like B is B. -4.
Oh, okay. Hang on. Yep, I agree. This one is B because of this -4 right here, and this has got that -4 in it. Very good.
And then is C, B.
No, I feel like we'd be better off if we rewrote this. If we rewrote this as
4 there.
1 over x plus 4x over x, and then we canceled out those x's, it would become 1 over x plus 4.
Yeah.
So now this is going to go to 0 again as x gets really huge.
So it's A.
So it's going to go to a +4, yes. And then this one, same thing. I could break this apart, make it x over x plus 4 over x, which means that's going to become a 1. X over x is a 1 plus 4 over x. And as x gets huge, that gets closer and closer to 0. So it's going to get very close to 1. So if anyone, oh yeah, this one here has got a asymptote at +1. So that would be C. So they do ask us then on the next part, oh, wait a second here now, I'm a little bit confused. Oh, they got more of them for us here? Oh, they did ask us more of them.
Some of them apart.
Okay.
The ones that were broken apart.
Oh, and then they put them together. Okay.
Yeah, because then H is A. And C.
Yes, you're right.
C.
This is
And
A.
G is C.
G is C. Yes.
And then
This one.
is F E or no? Is F D?
Yes.
And then E is B.
Correct.
All
right.
I'm good at matching. That's it. Have you noticed that, Bert? I'm really good at matching.